Hi everyone and welcome to this video. Basically today in this video I'm going to talk about the netYCE framework and actually show you a demo and explain to you with just a few slides what the framework is, what netYCE is, and how it can help you to automate any type of network. Because think of netYCE as a framework, an open framework which is out of the box, basically empty. And this might sound strange, but I think it's very logical if you think about how to start automating processes, changes to your network, across multi-vendor networks, across multiple domains. You want to start out with actually doing the same thing that you currently already do and actually structure it, put it in netYCE, and have netYCE do it for you. So you still do the same work that you normally do, but you structure it within netYCE. And there's a huge variety of things that you can do. So we'll focus on a high level sort of overview and give you like an in-depth demo. So you're looking at a slide which is truly the positioning of netYCE. If you understand what now happens in most networks, there is a lot of manual label involved. So the engineer typically logs in onto a device, a Cisco, Juniper, HP, whatever it is, and he executes the specific commands that belong to that vendor. So iOS or Junos or whatever specific syntax that engineer knows, he types in directly onto the production devices. Now, of course, that is causing quite some risk. It turns out that 80% of network outages occur due to manual errors, typing in the wrong thing, maybe using the wrong parameters, figuring out first what is configured on the box. So what netYCE allows you to do is actually work through one single application. The way you structure this, there is 3 layers within netYCE. And let me just already show you the application. So here you can see we have 3 layers: design, build, and operate. You see underneath there are a whole set of tools, and each of these tools has a whole set of subtools that belong to this category. So let's go back. So we're going to start off today using the service operational tools, and then as you would like to automate, you can use the database, which is the middle layer. It's really a hierarchical database that allows you to store any type of information about your network, but it's done in an abstract way, so not vendor specific. Think of this as the database that contains all of your objects, nodes, port configurations, functions, topology, trunks, VLANs. For now, we'll just start off with the operational tools and then explain bottom up the use of the database and how you can actually fill the database in an automated way. If you look at this picture, what is the first thing that we're trying to achieve when using the operational tools? And I'll use this slide for that. We want to give a customer the first 2 blocks of capabilities to get in control in a more centralized way of all the operational changes that are happening in your network. The first step is you can set netYCE to go out every day to your production devices and collect the versions, the running version of that day, of that hour, maybe once a week, whatever you want to do. So you can set a poller. You are able to look at the timestamp differences line by line. You can compare them, get alarms on them, things like that. Let me show you an example. So I have a database that is from one of our customers, and this is the tool that we can start off. You can set a polar interval as many times as you want, and these are just a few configs that we fetch. So the database is not so full, there's only one. If it has a timestamp, and if you would have had 2, you would see line by line the differences that were happening outside of control of netYCE. Now, this function allows you to get some first control over what engineers and operators are executing in your network. Let's move on to the second one, because I think that's where things start to get more interesting. Instead of actually going through the device directly, you do the same thing, but you use netYCE. So let's go back again, and we'll focus on this tool. It's a noteconfig tool, so we can pick any type of customer, basically, or any type of device. So here you see a list of devices. Now you only need to start up with the credentials of the device. So you put them into netYCE, we can import them, and you can select one. Let's say it's a Cisco one, and you can type any type of command in Cisco language that you want. You can send it out. So whether this be like a show config of something, or whether this is a reconfiguration for VLANs for that specific node, or a change on the device. So it is basically as if you were on the command line. Now you type it here. Now, what is starting to get more interesting is that we can allow you to use parameters that will be substituted from netYCE. You can use relationships, you can use templates. So we're going to quickly go over these functionality. Device provisioning with parameterized jobs. Now, you can do this already by using brackets. Anything between a bracket, you are able to get that data from the database. But you can also share and save jobs. Actually, first save and then share, of course. You can keep them private. If you want to share them with your team, then any user that is in the netYCE system will have this. Now let's just load a saved job. Now here you can see this is the text that already somebody thought of. It's a simple one, an enable secret update for Cisco devices. And this engineer thought that might be useful to actually share this one with his colleague. Now we will focus on this in a minute. But what this will do, it will actually execute when I select this device. It will execute these lines, and you can schedule it to go now, tomorrow, or any time interval you want. You can do it on one device or many devices, because these parameters will come now from the database. So you start to structure your information into the database, which is the build database, or you import them, and it will come from there. So now you can say, okay, let's evaluate. Let's take this out for a minute. We can evaluate these commands for a Cisco selected device, right? As you can see here. And you see that if you are happy with the specific variables, you say, okay, that's fine. I like this, and I just schedule it to go out. Are you sure? Yes. In this case, it's only one device. And a job is created. So we can go to the job log, and you can see there was one there. It's a command job for an enable secret update. Very simple example, and it will go out. Now also here you can see that there are approval mechanisms. So you can configure netYCE that if you have your engineers maybe issuing more than 10 or 50 changes to a network, it needs to be approved by a colleague or a manager. So you can configure this. In this case, it will just go out. So netYCE will then log in to that Cisco device and execute this job. You can then open it up. You can look at what it's going to do. So netYCE will go out and log into the specific device. netYCE is smart enough with its vendor engine to figure out what is the best way to connect to the device via SSH or Telnet, whether if this device has netconf or any advanced standardized interface, we will connect in that protocol. We can also actually have netYCE connect to a vendor API, as we do with, for example, Arista and F5. But basically, netYCE will do it for you, and the engineer can get the results back as if he were behind the command line. So in the job log, he can see, now in this case it's running on my virtual machine, so these are all aborted. I can open this one up, and it will show me a full session transcript as if the engineer would be on his command line. So netYCE is retrieving the error messages. Typically, the more you structure in netYCE, we see customers up to 99% first time right guaranteed. And we will also make sure that the 1% can be fully automated as a rollback mechanism. But I think what I want to show you is that netYCE will give you the transcript as if you were behind that device. I hope that makes sense. Now, instead of having it substitute only some parameters between those two brackets, we can also use relationships. We can also use conditionals, even use functions to calculate stuff for you. So you can put a lot of your knowledge either here, or you can put them here between those brackets. These are templates. Let me show you how this works. So templates, we organize this here in the build phase. Let's go there. So here we have templates. And you can make templates for nearly anything. So any device has a template tree, which start off with the main template, calling upon sub-templates, and then actually having port templates. So for a specific function as VLAN, this is the text that the engineer has put in there in a Cisco language. And as you can see, we've substituted these parameters from the database. Nothing fancy here. Let's see if we can find a more complex one, a fast Ethernet port. Now here you see already two other things. Here's an @ sign, which indicates a relationship. So in this case, it will generate a number of lines depending on the number of relationships between VLAN ID and the port subnets. So this can be either 1, 20 or 100. And if you execute this template, it will generate a number of lines. Now the other thing that you see is that netICE offers you, with these vertical pipes, the possibility to put in conditionals. So see this as an if statement. If the port shut status is yes, do a shutdown. If it's not yes, do a no shutdown. Now you can also include, if it's OS version 12.3 from your iOS, then use these command set. And Cisco might have had the next release 12.4, then they might have different syntax lines. So you can put them all in there. You can have exclusions, exceptions for specific nodes, for specific customers, for quality of service. So you can put all your knowledge in a template. And instead of actually typing that into the box, you can issue this template. Let's see how it would work. Let's see if we have an example here in the database. So this is just calling upon a template, right? They've called this template, whatever, @CMG, it's the name of their network. And instead of typing the name, I can now look at it's probably a Cisco device. It will evaluate it. Okay, it's not a Cisco device, so maybe it's also good as for this example. Probably it's a HP device. So now we can evaluate this template. There you go. There's still some errors in here. I'm just selecting a random one out of this database. There's still some things missing, so the engineer needs to fix this, but you can send it out. Now the good thing about using templates is that I can create a multitude of templates with the same name, but put in different syntax for both HP and Cisco. So if I would create a template also for Cisco, as I just saw it didn't work, but I put in the Cisco syntax for this function, then I can also select both the Cisco and maybe 100 of different devices amongst Cisco, iOS and HP, and I'm able to send it out. Now what you see here is any job that we will schedule to the network will use a scenario. If you don't specify anything, we'll use a command job scenario, which means that netICE will log into the device. We will fetch the running production version of that config. So whenever something goes wrong, we can do a rollback to that device. Yeah, so you can guarantee that the jobs that you schedule through netICE can never break anything in your network. You can in detail specify what you want to do. So let's go back to this example that we just had. Okay, here you can see that this engineer wants to send these jobs out to a variety of nodes, but it's using this scenario. It will import the configuration as I just told you. It will do also updates on specific routers, maybe using some specific steps for netICE to deal with a production device. Right? This can be a variety of things. I can show you, you can save these things like the templates. For example, this one. Let's say you want to use this div config. Before executing that job, we will collect the running config. We will compare it with the one from yesterday with a different timestamp. And you can say here, if there is no difference, proceed. If there is a difference, maybe roll back or send an alert or an email, whatever step you want to do. So you can do very granular things like a mini script, right? We have out of the box a whole set of these for startup configurations, for node migrations, for network migrations, whatever you want to do. Now, as you can see, these also work with parameters that get substituted, also maybe with relationships and conditionals. But the most important thing is you can start to standardize and structure one network engineer's knowledge to be reused by others, to be used in a multi-vendor way, across a large number of nodes, and netICE will orchestrate this, and you have a centralized process. Okay, I hope that makes sense. Let's see if we actually missed something here. So I said this is only focusing on device provisioning. It's sharing jobs, parameterized jobs using templates, also for multi-vendor jobs. I think I mentioned this. Now, there's one nice tool here as well. It's the bulk OS tool. It's a multi-vendor OS upgrade tool. We have an upgrade tool, and let's say you want to, I have no idea which network it is, but let's figure it out. All these nodes, we can now schedule netICE to go out and figure out. In this case, there are many, as you can see. You can select them all, or maybe just a few of them. netICE will go out and go through these steps, do an inventory, we'll figure out the running OS version. You can schedule the target OS version, you upload it here, and netICE will go out, will figure out if there's enough memory available. Do it, but as you can see, you can do this in a bulk way, and netICE will actually go out, create jobs, update it, and it saves you a hell of a lot of time. Okay? Now you can add more and more knowledge, as we call this context-aware information. So if you only have login credentials for the devices, upload them to netICE, we can do those two first steps. Now, the more you know about your network and even your services and your customers, you can put them in the netICE database and use all the tools of the build layer. Let's go there. Okay, now this is the main view of the application, and you can see we've organized clients, sites, and on each side there are nodes. So if I select a specific customer, you can see they have multitude of sites with different types of networks. So this is a headquarter with a redundant headquarter connection. This is just for connecting an ATM machine, so it probably only has one. You can also look at how netICE represents this data. So as you can already see, we have the topology in our database. You can fill it either by creating a service, creating a new node. Let's see if we can actually create a new node. Now here you can see already things that we modeled in netICE. So I can add in the database a new switch. Either it has 24 or 48 ports, and we will start something that we call a service model. Right? So 28 steps have now been updated in the database, and this is the modeling piece. So instead of doing it manually, and I can show you a node, and I can change the port, I can give it a new template, I can look at the topology, I can see what is connected to what. Now this one is now connected to the new device that I just created because that model did everything for you. But the most important thing to realize is that it's a database that contains your network abstraction of all the connectivity things, how VLANs get transported. Here you can see across this link from left to right, it's using an outer speed from this port to the other device on the other port. It's using all kinds of VLANs that automatically are transporting across this node, but everything is in the database. Now I can do this with a model, as I just showed you. I can also do this by just manually creating a new site, creating a new customer, creating a new device, connecting it to the other device. So these two layers here, design and build, think of this as the database with your network abstraction. And this is the piece where you can put some models and automation steps to do it for you. So instead of clicking around in the GUI on the middle layer, we can have models to automate these steps. And all these parameters can then, of course, be used within all these tools that I just showed you. Right? So you have a model-driven, design-oriented, intent-based, in the build database, process to automate these changes. And the nice thing is you can also invoke this from the API. And let's show you how the modeling works. We start out with actually modeling client types. Now for the database I just showed you, they actually have 3 networks in there: a fabric path network, a RainbowNet network, and some RainbowLAN network. They've given that names. And each of these networks, you can say, what kind of site types do I have? Because some of them might be standardized on this type of architecture. If you have a redundant headquarter, so they've given it names, HK, HK+. These are the options. Right now, this is the one I actually just showed you. It will, and we've broken down, by clicking on that button that I just did, it will execute the steps in an automated way. And let's show you. There we have the service type. So let's actually see the one we just did. Now, there are many things in there because they automated the whole fabric path network as well. Let's see. This is the one for one switch. And as you can see, these steps are basically the steps that I can also do manually in the build phase. But why would you click around and create a device, define the blueprint for the ports, give it a VLAN, an IP address for management domain, give it the VRF names, the net names, the node types. Why would you do this if you can assign these steps, right? So service types, think of them as engineering steps that you would normally do. So if you want to create a new one, if you want to do it for VLANs, for IPVPNs, for adding in whatever you want to do. So I mean, anything from an engineering perspective, you can now automate. And now I want to show you how this can work together in a very nice example that we did for a service provider. Let me get that slide here. So this was done for a carrier Ethernet network that also connected to a MPLS core connected through a Cisco. So we have both Ciena in the carrier Ethernet domain. We have an MPLS core. And in the demo that I'm going to show you, I want to add 3 CPEs. So first create it in the database and then create jobs to go out to all these red dots. Because if you think of it, if an order comes in to give this customer an IPVPN layer 2, layer 3, you of course need to configure the CPE. Then you need to connect that CPE to a certain port. Then you need to configure the ports to get them communicated. So this is one ring. It's the main ring. There's another ring, sub-ring. So depending on where this customer lives, you connect CPEs, you create CPE configurations, but you also create jobs for all these devices to go out. The information setup is actually a bit more advanced in this customer. So we get all the information from their OSS system. They use Kramer for most of it. So the order breakdown is already done and all the customer name, service ID, VLAN numbers, CPE name, all that stuff is coming from Kramer. We get it through our API. And for the demo now, because we don't have a live integration here, I'll show you, we actually put it in a separate database and we will still invoke our own APIs to provision the whole thing. So let me show you the second VM here. Okay, so here is this customer. So this is the service provider database. You can see there are multiple rings here. And there's only one customer. Now I've opened up 2 tabs so I can show you the progress. I'm going to create a new customer called 503. What we did, instead of actually configuring nodes, you want to have a far more smarter way. So we have created this wizard. It's a carrier Ethernet network wizard. And it will show me the information that we have received from Kramer. Right now, I click on this customer and we saw earlier, let's go here, it's not there, but now what happened is that netYCE is invoking its own API, and so this service type is being done. So if I refresh my screen, now there is a customer 503. Now this customer doesn't have any sites yet, it doesn't have any CPEs yet. So let's continue to walk through this wizard. I need to give it a specific service ID. Now it says, okay, I need to add a CPE. So the operator, the provisioning engineer, in this case, clicks on that button and 2 things have happened. So let's refresh this one again. Now 503 has 1 site, 1 node. You can open up this node. So this is the information we've received. Now let's do this 3 times in a row. So I'm going to add another CPE for the other ring. Do it for the 3rd one. And as you can see, this data that was not put in by netYCE, we just received externally. Okay, so now you can see we have 1 customer, 3 sites, and on each site there is a node with a different name. Now we're not there yet because, as we showed you here, we have now prepared in the database 3 CPEs, but now we need to provision all these other dots. Okay, So we're just going to continue with this wizard, and we are now preparing the creation of other service types that we modeled. And we prepared for one node all the changes. We're going to do it for the other node and maybe for other devices in that infrastructure. We've done it 3 times, and now the database is ready. And now you can see that here are all the jobs that netYCE prepared already, probably about 23 jobs that represent all these orange dots. So one job will go out to configure this port, one will go out to configure the Cisco port, and once these jobs are all executed, so let's do this. Let's select them all. Maybe you want to do it now or tomorrow. Let's do it now. We'll schedule it. Of course, you can say maybe not the ones on the core. You can deselect them if you want. And here the jobs are now being created and submitted to the network. When you refresh this, you can see here are all the jobs that are doing individual things. So one is going out to an LSR device to configure the port on the downlink. One is going to provision the layer 2 VPN. The other one is creating the CPE configuration and the ports. So in 40 seconds, I have now activated a layer 2 VPN across 3 sites across a carrier Ethernet network that also involved making changes to the MPLS and the Cisco environment. I hope you see how powerful this is, and that we not only do device configuration changes, but also service. So let's go back to this slide. So in this case, we use the modeling capability. So we actually modeled the carrier Ethernet network. We also modeled the standard type of changes. We can automate this everything in a wizard. You can use the scenarios, of course, to deal with specific checks on your production device. You don't want to have netYCE override, for example, a certain VLAN number. Anyway, I think that's what I want to leave it for now. I hope you enjoyed this. We also have a couple of blogs on this, which will describe this entire process in more detail. Just go to the website. There is a try now button. Just request an account. There's really nothing to it. You fill in your details and you automatically get access to the wiki, because I can talk as much, but there's so many capabilities that netYCE has. You can click around, you can take a look at how we deal with templates, parameters and functions, how you can use sub-templates within the template, how it's all done. So I think for the techie guys, just go in there. At the same time, once you get this account, you get access to the online demo system that runs on Amazon server. It has a variety of networks, but you can click around and play around for your own experience. Okay, thank you very much, and I'll hope to speak to you soon. Bye.